Well, we're here for another Tech Talk with Paul and Al, and what have you got there, Paul?
Today I have one of Scott's best, biggest, baddest power amps from the early 60s, an LK150. This was the one built from a kit. We won't hold that against it. 6550 outputs, double rectifiers, 7199 preamp phase inverters.
Isn't it beautiful?
Tons of iron. Hard to imagine. Got this in supposedly working condition. Somebody bought it, but it hums. So I tipped it over and just about cried at what has been done to this amplifier. This is absolutely horrible.
What a mess.
They have added chokes where chokes don't belong. They've replaced capacitors, and they sort of did it right, but this had 80 mic capacitors at 500 volt. They have put 800 mic capacitors in series, which gives you 400 mic capacitors at 1000 volts, which is way too much capacitor. They screwed with all the equalizing circuits, and all the resistors have been changed and moved. One of the scary things like this, that's just inexcusable. The tie strips are riveted in, and half of them are loose. The rivets are loose, but they're used for grounding. And you can see where they have grounded things up and through and bridged, and resistors that have been spliced. These were supposed to be bias level pots. It did not have bias balance as it was designed. They've converted it to balance pots with no way to adjust the basic bias voltage, therefore you can't regulate the current. That's wrong. I mean, stuff like this is technically, this yellow wire is technically a ground that they've clipped on here, gone up here, just anywhere they wanted to put a ground, they just stuck another wire. This is where one of the chokes was inserted in series with the B plus coming from the power transformer. They take the center tap of the rectifier filaments to supply the B plus to the first filter. Added a choke here, added a choke here. I fired it up, and yeah, it works, but it doesn't sound right. It's got this background hum.
It looks sort of dangerous for that connection that coming out of the big transformer.
Well, they had duct tape on this.
Oh,
there's
duct tape?
There's duct tape.
Oh my God!
They had duct tape on these. Supposed to be.
Was it Larry the Cable Guy worked on it?
It looks like it. Supposed to be a 20 ohm 40 watt resistor between here and the filter cap. Well, they put a choke instead. And these are little nothing chokes with a DC resistance of about 75 ohms. Who knows how many henries they are, millihenries. They won't even read on my tester. So we're dropping 80 volts across this one because you're hitting it with ripple off the rectifiers. So you're dropping 80 volts here to the first filter, so the B plus is low. And you look at the plates, and yeah, there's hum on the plates.
Well, where would they put a choke in anyway?
Well, the thinking is that if you put in chokes and bigger capacitors, you can get more bass because you have all that stored energy. Well, if you read some of the tutorials on the internet, there's a lot to be said about this amplifier. If you go to solid state rectifiers and put big ass capacitors in it, you can gain some more bass because you've got this reserve power. But the tube rectifiers can't crank out enough current to fill a capacitor that big to do you any good. So this was a waste of time. Adding the chokes was just wrong unless it needs chokes. And with a push-pull amplifier, any residual hum you've got at the front of the power supply, and the hum that shows up on the plates of the tubes doesn't show up much on the speakers because it cancels itself at the output transformer. But the bias is wrong, there's noise in it. You can only imagine how much noise this rat's nest is generating. It's got normally a tube amp like this with negative biased outputs would have the cathodes grounded. Well, these cathodes are grounded through 2.7 ohm resistors, so you can read the voltage across them, and you push a little button up here.
But it looks like those are piggybacked.
Well, they paralleled them.
Uh-huh.
It's supposed to be 2.7 ohm. They've got 2 6s in parallel. That's close. But you're supposed to be able to push this button, read the voltage across that resistor, and adjust the bias for that red spot, whatever that is. Well, this little meter's bad, and there is no bias adjustment pot any longer. Where the bias pots are now the balance pots. They added volume controls to adjust the input level, which is not a bad idea, but it's not original. Power switch is, you know, piece of crap.
That's not the original power switch.
No, it had a knob switch like this one.
It sounds like whoever worked on this had just a little bit of knowledge and was dangerous.
I wonder how many people over the last 50 years have screwed with this amplifier.
Well, the thing that gets me is those capacitors are sitting in there and they have...
Well, the first thing the new owner says was, those are ugly. Can you cover those up? Well, I could put sleeves over them, but...
Well, isn't that masking tape?
That is masking tape.
So they took a flammable masking tape and wrapped it around the capacitors because they were too small.
Yes.
And yeah. Oh, that's just frightening.
These are coming out, and better capacitors are going in.
At least they have great tubes.
The tubes appear to be
from the factory.
Yeah.
And the thing about it is, the H.H. Scott people, they knew how it should have been built.
Yeah. The original build was so simple and clean. And this is just a rat's nest. Now, it does work, but you've got these switches that change the feedback depending on the input voltage. Well, those switches, this one's coming apart, and this feedback network, I don't know if it's right or not, but it's, I mean, that just makes me want to cry.
Well, the thing is, you know, putting all the duct tape in and the masking tape makes it sort of a fire hazard, too.
Yeah. I suspect the owner bought this off of eBay and probably paid $1,000+ for it. There's a lot of that. But the chokes are going to go. That resistor is going back in like it should. Get the voltages back where the book says they should be.
Well, you know, it's like taking a Porsche and putting in a Chevy engine.
Yeah, it's sad. Well, a lot of this tube stuff, they just know that they can improve on it. And there are some things you can do to improve an amplifier. And the bigger caps is one, and some other
Well, I
things.
mean, when they're going to the thing of piggybacking resistors in parallel because they just don't want to spend the extra $2 to buy the right size.
Trying to find a 2.7 at that wattage may not be easy. And you need the bias balance adjust to match the tubes. Why Scott didn't build it with bias pots, I don't know. These were originally used for bias level. The grids were tied together through a resistor. And this was bias level, not bias balance. But they just moved it to the center tap, grid, 100K resistor, kind of like the schematic. And what bothers me, the schematic's laying up here. Right there. Where's the power amp? Okay, there's the grid resistors. That's ground. Here's the 100Ks with that pot in the middle and the B- going to the center of the pot. That's all well and good. But there was a dropping resistor right here from the midpoint to ground, which affects the voltage drop on the bias pot, and it also ensures that there's no crosstalk between the grids across this point. Now, without that resistor to ground, you have the possibility of drive crossing over to the wrong tube. So there's all kinds of things to think about when you modify a circuit. Maybe some of that stuff was there for a reason. But I'll get it all up and running and see if I can't clean it up. They're supposed to sound amazing. But this one, I'm surprised this one worked at all.
It's scary. But we'll do another one and talk about what you did to resurrect it.
Yeah, there'll be another story on this, but I wanted this captured before I did anything to it.
Yeah.
This is just mind-boggling.
So this is part one.
This is part one. You've got a good picture off the internet of what it was supposed to look like from the factory.
Yeah, and we'll just post this.
And you would swear it's not the same amplifier.
Well, good, Paul. Well, thank you for another Tech Talk.
Yeah, I thought this was interesting.
Yeah, well, we'll keep going on this one.
Alrighty.
Well, we're back with a second part of a Tech Talk with Paul and Al, where he's resurrecting an H.H. Scott amplifier.
Yep.
one of the big collectible amplifiers, and we can see that looking inside of it, it looks a whole lot neater than what it was before. I'm saying it's missing chokes.
Got rid of the chokes.
Uh-huh. What are you doing there? Putting power on it or speaker?
I'm tacking a speaker onto it. This is its maiden voyage after I cleaned it up, got rid of the chokes, put the resistors back in where the chokes were, according to the book. They normally were running this way, but I put them here on terminal strips.
Did you add the terminal strips?
Yes.
Okay.
Cleaned up the grounds, made sure all the grounds were interconnected properly, because they were scattered. The rivets in the tie strips are bad, so you couldn't count on the grounds. Cleaned up in the input phase inverters. I would like to just rebuilt them, but there wasn't time. So I cleaned them up and resoldered and redid the feedback networks. The bias set buttons no longer work because of the modifications. The damping switches don't work because that circuit's been eliminated. They added these volume controls to put gain on each channel, and they're fine unless you lower them from maximum and feed it a square wave, and the square waves start to round. So that wasn't a good idea, but I can't help that. Funny thing was, I got it all done, and the last thing I did was replace the power switch, which was missing. And I've had a power switch in my junk box, which the only one I could find that would fit. I found a nice toggle switch, but you'd have to drill the hole out, and you don't want to do that on a Classic. So I found a switch, a turn switch off a lamp in my junk box. Looked nice. And I turned it on, and the filaments came up. I thought, great. And I turned it off and back on, and I got this, it blew the fuse. Got this, and it blew the fuse. I thought, well, what the hell has happened? I spent 2 hours double checking everything. I hadn't even put the rectifiers in yet. So I thought it's a filament short. I was convinced the transformer had died. About bedtime, I said, it's got to be something stupid, and it was. The switch I pulled out of the junk box was not a switch. It was a switch/dimmer. 2 wires, turn knob, got a diode hidden inside for half brightness, transformer, half-wave rectifier, blow fuse. Pull your hair out, think you've lost your damn mind. Jumpered the wires back together, put power on it, everybody's happy again. I'm pulling almost no current right now, and I am about to put the output tubes in it and find out what happens. So it's, I got it running at 100 volts.
You just killed the power.
I just killed the power. Put the rectifiers in. I've got dummy load resistors on both channels, big ones. So, and I've got an amp meter there, I've got an amp meter right here. It's on 6 amp scale. It takes these rectifiers a long time to come up. And I don't have input to it yet. Amperage ought to start to come up here in a second. Everybody's lit. I don't see any smoke. I've got a speaker, should be on this.
I smell something heating up. That may just be your soldering iron.
Well, I hear the amperage isn't coming up, but I've got a transformer.
Well, that's an input, isn't it? So we're injecting your hum noise. And
I've got my finger, so yeah.
It's amplifying.
This transformer has a tendency to groan once in a while, but the running amperage,
it's not bad. It's pretty.
I don't know why it's doing that. It's got a.
Well, it's going to pull a certain amount of vital current. Is that too much?
That's not bad. Let's go to times 10 mode and a little high. pulling just under 2 amps. But that's mechanical vibration. But
Hysteresis. Noise.
I'm knocking the speakers off, or whew. It's got a lot of gain.
That's pretty good gain.
But it's working, and it's not smoking.
That's one channel.
That's one channel. Yeah. That resistor gets pretty warm. That's between the rectifier and the first filter. That one does almost nothing. Cathode resistors, those were there so you can measure the voltage across them, or the current, to set the bias. And they converted the bias level adjust pots into bias balance pots, which is okay. Only the resistor values are such that you really can't switch the current very far. But before I overhauled it, I looked at it on the scope. It looked good. I've got a little gain issue. One tube's a little weak on the one channel. But other than that, I'm pleased that nothing is smoked or arced. But spending 2 hours last night figuring out why it was blowing fuses.
And you didn't have an on-off switch.
I had a diode in series with the on-off switch. Dumb. So when you use stuff out of the junk box, you're just asking for trouble. I gotta find out which laminate is buzzing, because that's not supposed to buzz. But it's working, and I hear nothing from the speakers.
And if you actually put audio in, you'd probably get good sound out.
Yeah, the audio jacks are on the back end, and this thing weighs a ton, so you got to prop one corner up to get the
or set it on its side, which may not work.
Which is hard to do, as heavy as this thing is. See if I can.
Be careful.
Yeah.
You don't want to fall over on your tubes.
No. Prop it up right.
And see, the one thing about this is it's got high voltage.
Oh, yeah.
It's not like a little transistor.
400 volts of high voltage.
With a good amount of amperage draw, if you had it all of a sudden.
This was originally built with 80 mic capacitors in the power supply. And somebody upped it to 400 in the belief that you get more bass.
Well, it might get a little bit of a little hum, but
okay, there's an input signal. Oh, down.
Can you hear that?
Scale. I can hear that. That's about 9K. We were doing an auditorium.
yeah, the right people, you could kill them with that high frequency, and we wouldn't hear it.
No. But anyway, so far so good. I've got to figure out.
Yeah, some people are really sensitive to that high frequency.
I got a guy at work that really freaks out when you start doing that.
I know they hate that high frequency. You have to be careful, because when you get older, you can't hear it.
True.
And then you make a high frequency sound out of something, and it just drives people crazy. You don't even know what's going on.
Well, we did an auditorium today, and of course we had to sweep the amps, sweep the speakers. And it embarrasses me. I have to holler at one of the younger guys to see if they could hear anything above 10K. I used to be able to hear all the way out to 16. I hit 12, and I'm like, anything? Oh yeah, okay, good. So I stopped at 10.
Well, you know, the thing is, when I was younger, I could hear the 15, 734, 1834 horizontal.
So could I.
And you could tell that everything it was running.
Let me turn this
Because the TV made that high frequency sound.
Yeah.
The flyback transformer and all that stuff made a noise. I don't know where that particular noise is coming from, but it's coming from the high voltage section.
Well, it's flyback.
Yeah.
Flyback and the yoke. But anyway, so far so good. But I hate to have to holler at the younger guys. Can you hear that? Yeah. Okay, fine. Trying to do an auditorium, and
well, you could see it with a metering of some kind.
well, yeah, I had a spectrum analyzer in my hand. I can tell where the notches are, but you know, just trying to decide, do the speakers actually produce that frequency? So we were setting the graphics to put the boundaries, And it's an elementary school, so nobody needs to hear about 10K anyway, because it's just kids screeching. But we had old speakers, and they didn't do a thing below 100. But the room, resonance-wise, comes alive at about 200. I mean, it's just like, whoa! So we notched everything out below 200, and notched everything out above 10,000. And no matter what we did, the room's peak was at 1.5K, so that's about as good as it gets. So we called it a day and went home.
A lot of times the acoustic in elementary schools are not that good.
No, this one wasn't. This is an old elementary school, but 250 watts of amplifiers for nothing. But that's the way schools are these
I remember
days.
back in the 50s, they just put one big speaker up in the
You
front.
know,
And
noise reduction, graphic equalizers, wireless mics, portable monitors. When I went to school, we had one little dinky 6L6 amplifier that they carried from the gymnasium to the basketball court to the auditorium. Oh, well, those were the days. Okay, this is going to live. I thought last night I was going to have to shoot myself, because if I told the customer this power transformer burned up on my watch, I'd never hear the end of it. Turned out it was something stupid I did, which is usually the case. But who would suspect that a little old Bakelite black light switch would have a diode hidden in it?
they did those things.
So I should have kept it for the video, but I was so pissed. I got a pair of pliers and crushed it. And I said, yep, there's the diode, and I threw it in the wastebasket. But when you use the stuff out of the junk box, you're asking for trouble.
You know what happened was you went away from the problem, and that's sometimes when your answers come.
I'll tell you what I did is I thought, this is stupid. This thing's been working. And I lifted all the leads in the transformer, thinking I had a filament short or something.
That was a lot of work.
I could have carbonized sockets. I never saw any arcing. I lifted all the leads off the secondary, and it's still sucking current. I put it on the Variac and ran it down to like 40 volts to save fuses and save burning the transformer up. Same thing. I thought, there's only one thing left, and it was fine till I put that light switch in. And I took the switch out and soldered the wires back together and flipped the switch. No amperage. I thought, son of a... Got the switch, cracked it open, and yep, there's a diode. It was off, high, low. Using a diode in series with the line current to dim a light bulb. Who would have guessed? So, solved that problem. But finding a light switch that fits, or not light switch, a power switch that fits this small hole is difficult.
Yeah, you might find some at Tanner.
Tanner didn't have it. They had a nice toggle switch that I really liked. It's chrome, and it lights up with an LED. And it's wired through here and the case of the switch. Well, you take a resistor and go to your filament, you've got power for the LED. This would look great. But it requires drilling the chassis, and I'm not willing to drill a chassis on a classic.
Yeah, and that would not be original.
And there's been enough crap done to this the way it is. I mean, what they did to this is just a crime. But I put it back about 60% original, left some of the mods in there.
And actually made some improvements on resistor mounting.
Resistor mounting is a little better. And they added screen resistors, which I don't approve of. I called a friend of mine who's a design guru. He goes, well, yeah, that's really not necessary, but if they're in there, leave them. So I did.
Well, the thing is, this was all hand-built originally.
Yes.
Yes. It was going down an assembly line, and there was people just soldering on a section.
Probably a bunch of women. It's funny to think about. If you ever watch these old industrial films, most of the hand-wired electronics we have today were made by women. They had the patience, the time, and apparently the agility to do this. But that's women are unsung heroes in the electronics industry, because you never find them in design or engineering, not then, but they sure built the stuff for us.
Especially during the war.
Especially during the war. Yep. So that's the saga of the Scott. It's an an LK150. Pretty amp. I can tip it over in your direction. Let me see. It's got a fuse right there. It's sitting on. I turned it off. Yeah, there's There's the top view.
Yeah, but you're not going to get rid of the tape.
I'm supposed to go and take some dead electrolytics and cut them off and pull the guts out and make sleeves to go over that because the owner doesn't like this. And I
Well, I
don't
wouldn't
blame
either.
him.
But is that tape safe?
Oh yeah, well they're insulated to start with.
Yeah, but it's burnable.
And they don't get hot. So I'm not worried about the tape, it's just ugly.
You ever worked at this at one time, didn't care.
They used what they could get and made it fit.
Mm-hmm.
And when this came out, these had cardboard covered capacitors because these are in series for the voltage.
Mm-hmm.
So they kind of emulated what, and this has the same thing, they've got them in series to double the voltage and have the capacitance.
Mm-hmm. So it's a voltage doubler.
No, they're just filters. They couldn't find 500 volt filters.
Mm-hmm.
They're hard to get.
Mm-hmm.
So they took 400 at 450 or whatever these are,
Mm-hmm.
and in series you have the capacitance in series, but you double the voltage.
Mm-hmm.
And they've got the proper balancing resistors.
Oh yeah, series and parallel capacitor
yeah,
rules.
and they put the proper balancing resistors in, which impressed me.
Mm-hmm.
And they work.
Mm-hmm.
And I talked to my design friend who says, well, the belief is with bigger capacitors you'll get more bass.
Mm-hmm.
But that's really only true if you have solid state rectifiers.
Mm-hmm.
Because the resistance of the tube rectifiers won't keep up with the
Demand
of the big capacitors.
Mm-hmm.
But it was too much trouble to downgrade it to hundreds, which would have been fine. I left it alone. If I ever have to rebuild one myself, I'll put 200 mic caps in series and get 100 mics, which would be fine at, some god-awful voltage. But it's good enough. It's will probably be resold on eBay soon. They never keep this stuff. He buys them and plays them and then flips them and brings me some more. I got a big Fisher down there that
Oh, look
needs
at
a
that
little
Fisher.
work. Yeah, they're complaining of hum, and I know it's got a bad output too, because I told him it's got one tube that's just not cutting it, and he's probably getting a little distortion on one channel. But tubes are getting so expensive, you hate to change them until you absolutely have to.
Well, I think they're only made in a couple places.
Russia.
Uh-huh.
And American tubes, if you can find them, are going for an arm and a leg.
Mm-hmm.
But that was funny, putting that dimmer switch in by accident and then wondering what the heck had happened. Usually when something goes wrong, it's my fault. And last night, it was.
Well, there you go.
There you go.
Well, it's another tech talk.
Yeah, but I solved the problem before I shot my mouth off or shot myself.
Yeah, that's good.
That's good. So, it's been fun.
Okay.